What's up, everyone? This is LeetCode 17, letter combinations of a phone number. As always, read the problem statement for yourself if you want. I usually like to just summarize them. We're basically going to be given digits, right, 2 through 9, and we have to return all the possible combinations, basically, that these numbers could represent. So, right, if you look at the picture, example 1, we have 2, 3, so the 2 could be A, B, C, could be any of those numbers. The 3 could be D, E, F. So basically all the combinations when we press 2 and 3 that are possible. For example, when we hit the 2, we could be grabbing an A or a B or a C. When we hit the 3, we could be grabbing D, E, F, right? And down here you see all the combinations. I think the gist of the problem is not that difficult, like understanding basically what it's asking. The solution is obviously more complicated, but I'm gonna go to this. So really, right? This is example 1, right? So the 2 can represent any of these, the 3 could represent any of these. So really what we're doing is basically, it's like going from pressing 2 and then we press 3, right? You can think of the 2 as a node, basically. And what can the node be? Well, it could be any of these, right? So we could have an A, we could have a B, or we could have a C, right? And again, the 3 could be what? Any of these. So really, we could have a D, an E, or an F. Something like this, right? Now that would be true for all of them, right? So it'd be something like this, right? So really, our solution could really be a D, a E, or a F, right? Yeah, and or it could be B D, B E, B F, right? B D, B E, B F, or it could be C D, C E, C F, right? All the combinations. So as you can see, that's basically what we're doing. The kind of gist of what it's asking you is not that hard. The solution's a little harder though. Now in terms of the solution, really what you need to keep in mind is how would you ever map numbers to letters, right? And because like you could have a bunch of if statements and all this, but it would just get too complicated, right? So actually the trick really to this problem is let's just use a hash map and map the numbers to the letters, and then we'll use that, okay? It'll make things easier, which is a little strange because you probably wouldn't think to do that initially, but it actually just makes the problem way easier, so it's worth it, okay? We're basically mapping the numbers, and again, the numbers are strings, right? That's our input. So this 2, 3 is a string. That's why we're going to map these numbers as strings to the actual letters, okay? So we're basically just mapping the numbers to the possible letters that it could correspond to, okay? And then we're going to obviously have to return an array. We'll call it answer. And now in here, right, is where our solution goes. Now really, this is actually a backtracking problem, right? Let me go back really quick. The reason this is a backtracking problem, if you can't tell, is because, let me see if I can delete this. That's probably too hard. The reason this is a backtracking problem is because this row here, oops, this row here represents the 2s, right? And this represents the 3s. Let me use this blue, right? So when we start here, we can go here, okay? And we built out one possible combination. Then we could go back up, and then we go down here. Then we go back up, go down here. And so we got this combination, and this combination. Now when we're at this F, right, we're going to go back up to this A, and then we'll move on to this B. And then from here, we'll go here, grab this combination, go back up here, here, right? Then we'll go here, grab this combination, right? So this is actually a backtracking problem. I'm sure there's several ways you could probably solve this problem, but backtracking, I believe, is the most optimal. And also it's just the simplest to kind of understand and implement. So that's what we're going to do, right? So let's create a function called backtrack. We're gonna have to have what? We're gonna have to have an index and a current string, okay? Now, the idea of how we're going to basically implement this is initially we're going to have a string that's empty, right? So when we're here at this A, we're going to start building on our string, okay? A, then we go to this D. That's our current string. Now, when our current string is basically equal to the length of the numbers, it means we're done, right? We can backtrack, right? Because obviously if we press 2 or 3, we're only going to have two digits, right? We're not going to have, or sorry, we're going to have 2 letters. Nothing more than that for our output. So then we can basically go back and, right, do the same thing. So basically our condition to know when to stop is when the length of the string that we're building out is equal to the length of the input, essentially, right? Hope that makes sense, right? I'm just saying, like, if you press 2, 3, right, you're like these outputs will only be of length 2. They won't be any more. So that's how you know you can stop. Okay, that's basically like our base case. Okay, we're gonna say if the length of the current string, and that's just the string we're building out, is equal to the length of digits, right? We can just do answer dot append current string, and then return. Okay. Now down here is basically where we're actually gonna have to start building stuff out. And the way we're going to do that is we're gonna use the hash map, right? And the way we're gonna use the hash map is we're gonna basically have to grab the index, okay? And let me just actually call this function, right? So we're gonna start at the 0th index and we're gonna have an empty string, okay? So what we're doing here is we're going into the digits map using the 0th index. So for example, might be a little confusing, so I'm gonna try it out in comments. So let's do example 1, right? Our input is basically just 2, 3, okay? So the index 0 is what? Is the 2, right? So we're basically going to go to the 2 in this hash map, and so we're going to grab ABC, sorry. So letters is going to be ABC. Now we need to iterate through each of those, right? Because as you remember, right, we need to go through this, and through this. So so when we do this, we're really returning, or we're really just getting ABC, right? So we need to go through each of those letters. So we're just going to say for letter in letters, right? We're going to backtrack by doing what? We're going to go up an index, and we're going to do current string plus letter, right? Okay, that's it. Because basically what we're doing is in this for loop, right? What we're doing, remember, we're iterating through this string ABC. What we're basically doing is, okay, for the first in the for loop, right, the first round, right, we have this A, or we're gonna recursively go into the backtrack function and go up an index, right? So we're going to actually grab, remember our input is 2, 3, so now we're gonna go to the 3, but current string is going to be what? Remember, it's initially empty, so we're gonna do basically add the letter, so A, and then recursively go into the function, and we're going to have to look at what? What is 3 DEF, okay? Now, this isn't current string, sorry. And we're going to look at DEF, right? And then for the second iteration of the for loop, we're basically doing the same thing, but we're doing it with B. So for our output, that's why we have AD, AE, AF, right? We're basically grabbing the A and recursively going in up an index so we can look at the 3, right? Okay, I hope that makes sense. With these backtracking problems, it's always helpful to really just go step by step in terms of like trying to understand what your code is doing, because otherwise you might get lost. Because there's like a call stack, right? So these problems can be a little bit confusing. So just make sure you understand what we're doing at each step. But yeah, that's this problem. I don't think it's too hard to understand. I hope my explanation was okay, but again, just make sure you understand your call stack and you'll be okay. Yeah, I hope this was at least a little bit useful, and I'll see you in the next one. Peace out.